The third and final way I have to do, or have to show you on how to do stoichiometry is the longer of the ways. But some people have more success with it than others. If the other two have failed you, maybe the table logic will be your salvation. So let's talk about table logic when it comes to stoichiometry. What you're going to do is you're going to set up what I call a Rum-Molsey table. R stands for reaction. So what I'm going to do is I'm going to copy the reaction exactly as it appears above into that location on my table. It'd probably help if I had started with the right equation, save me some confusion. So now that I have the right equation up and it's balanced, I write it into the R for the Rum-Molsey table. U stands for units, and it's the units you're given and the units you want. So units I'm given are 3.0 moles of sodium silicate. So 0.3. Whew. It's a long day. This is what I start with, and I want to end up with moles of hydrofluoric acid. So I'm looking for this, and I want it in moles. M stands for molar mass, in which you're going to put the molar mass of everything in the equation. So I'm going to pause you, and I'll come back when I have them all. Once you have the molar masses of everything in the equation, you're going to skip over the mole part, and you're going to come down to C. C stands for coefficients. So let's put the coefficients of each one of these. So this is a 1, 8, 1, 2, 3. Now anytime you go down the table, anytime you go down, you divide. Anytime you go up, you multiply. So we need to fill in some of the lines here. We've got to figure out how many moles of each of these we have. So if I want to go down here, once you make it to this lower section, all down here, moles burrow underground, right? So once you make it down here, you can go up from anywhere down here. The goal is to make it down to this spot, because this allows you to be anywhere else in the equation. So once I make it down there, I can fly around and go any which way I want. All right, how many moles of sodium silicate do I have? Well, I'm actually already done. I don't need to do anything here because I'm already at moles. So this is done. 0.3. I don't need to do anything in this area. So don't overwork yourself. Think a little smart. I knew how many moles I had. So I can skip to that step. Which means I'll have moles here if I fill in the chart and follow along. So 3 divided by 1 is 0.3. So now that I have this number down here, I can go elsewhere and go up. I can go up here. So 0.3 times 8. 0.3 times 8 is 2.4. I have 2.4 moles of hydrofluoric acid. Check to make sure we have the right number of sig figs. 3 sig figs. This is only 2, so we'll add a 0. Gives me a good 2 sig figs. I got a little lazy, so once we figured out the answer to the last one, I cannibalized it and didn't have to rewrite anything. And if you're working on your AP test and you have that ability, do that. Erase and then fill in the next part. So this next question talks about how many grams of water. So we're looking for grams of water now. X grams of water can be produced from the complete reaction of 0.8 grams of sodium silicate. Since we already know how many, what the molar mass of sodium silicate is, we can go ahead and as we go down, we're going to divide. As we go up, we multiply. So 0.8, see you later. 0.8 divided by 122.09, 0.0065553. Divide by 1 so we can get down here to the sweet spot, which I'm going to run out of space at the bottom of your screen. But I'll put it in green down here. Underneath, divided by 1 is 0.006553. And now that we're down in this sweet spot down below, the mole is free to dig underneath of all the problems in life and dig up here. So now we're going to start going up. So we're going to multiply that number by 3, and we get 0.1966. Take that number and multiply by 18, and you get 0.3538 grams of water. Double check your sig figs. I see 1, 2, 3 sig figs. 1, 2, 3. 8 pushes 3 up, and I end up with an answer of 0.354 grams of water. Now, important things to remember with this table. If you are not working with grams, you will use a different number here for molar mass. Say you had liters at STP. If it's liters at STP, rather than put the molar mass here, use that 22.4. Say that it was atoms that you were solving for. Rather than put 18 here, put 6.02 times 10 to the 23rd. That's Avogadro's number, because that's the number in between. This number, this column here, this row, all here in between are the numbers between what you're working with, the unit you're working with, and the mole. What unit goes between the unit you're working with and the mole? So I put molar mass here because you can never go wrong with having it. It's not a bad thing to know. Your grader may give you points for it, because I have seen AP tests where having the molar mass correct got you a point, even if you couldn't calculate the right number of moles. But do not be fooled. If you are not working with grams, you have no use for the molar mass. So while having it's not a bad thing, it will be if you don't keep straight what your units are. We were working with grams, so we put molar mass in this row. If we were working with liters, we would put 22.4 if we were at STP. If we're not at STP, you know that you need to go through Herbener. All right? Keep your stoichiometry straight, and AP chemistry is a breeze.